Hello guys, let us see in the continuation of communication system previous year gate questions part 2. So you can refer theory videos for all the concepts and derivations. So we will be proceeding solving previous year papers topic wise. Okay, so we'll proceed with amplitude modulation questions. So the question is, in an AM signal like amplitude modulated signal, the message frequency is given as 5 kilohertz and carrier frequency is given as 980 kilohertz. The AM signal bandwidth is how much? Okay, so see, I have written the questions in notation form so that it becomes little easier for you to recall. So you know already the AM signal. Let's say this is my 0, this is my FC, this is my FC plus FM, this is my FC minus FM. Okay, so here you have like carrier amplitude, here it is modulated amplitude. So the bandwidth is nothing but maximum frequency minus minimum frequency that will be required. So this is the total that is there. So I have already given you formulas in our theory. So that will be FC plus FM minus FC minus FM. Okay, so that is going to be 2FM. So basically for single tone message, like single tone message amplitude modulation, you have 2 times message frequency that is equal to bandwidth. So that is nothing but 2 times 5, that is 10 kilohertz. Okay, so this is how you can find out the bandwidth of your amplitude modulated signal. So carrier frequency actually doesn't take any role in determining the bandwidth of a amplitude modulated signal. It is all about the message signal frequency. So you have made proper. Let's take another question. In an AM signal, PC, like carrier power is given as 500 watt and modulation index mu is given as 100%. The total power in AM signal is, okay. So this is going to be very easy. You guys already know the total power PT is equal to PC into 1 plus mu square by 2, and PC is given as 500 watt and mu is given as 100%, that is 1. So you can write down 500 into 1 plus 1 by 2. 1 square is 1 by 2, that is going to be 3 by 2. So 750. Okay. So you have PC into 1 plus mu square by 2. So just very simple formula. I have already derived how this formula comes up. Okay. So you can see in theory subjects. Let's take another get questions. In an AM signal, the sideband power is given. See here, sideband power is given. Okay. And modulation index is 50%. Okay, the total power of the AM signal is. So how do you proceed? Like what will you do with this? So P sideband is given as 100 watt and modulation index is given as 50%, that is 0.5. Okay, so you guys already know that total power is PC into 1 plus mu square by 2, and the PC into mu square by 2 is nothing but your sideband power. Okay, so can you find out from here what is your PC? So PC can be PSB divided by this whole thing. So that is going to be how much? 100 multiplied by 2 divided by mu square is 0.5 square, that is 25. Okay, so this will get cut. So that is going to be 800 watt. So PC is found out. So if PC is found out, you can directly write down PT is PC plus PSB, like carrier power plus sideband power, or otherwise you can utilize this formula. PT is equal to PC into 1 plus mu square by 2. Mu is already given, PC you have found out. So this is nothing but 800 plus sideband power is 100, that is total 900 watt. So total 900 watt. All right. Or if you want, you can actually do this. PT is equal to one more method you can do is you have PSB by PT is equal to mu square by 2 plus mu square. Okay, why I'm telling this is uh, you have been given PSB. Okay, so PSB is 100 and PT total power can be found out directly in single shot. Okay, so I had given you a formula for eta, like efficiency, that was PSB by PT, that is nothing but mu square by 2 plus mu square. Okay, so this is another method to find out. So you have been given mu value, you have been given PSB value, you put this, what will happen? PT is equal to 2 times 2 plus mu square will come up. So 2 plus 0.25 divided by 0.25 into 100 was PSB. So that is total 900 watt. Otherwise, just now I solved PSB is equal to PC into mu square by 2. So with this method, you can find out your PC, and PC plus PSB is total amplitude modulated power. Okay. Let's move to next question. In an AM signal, we have been given upper sideband P USB power and a lower sideband P LSB power. Okay, that is 2 kilowatt. The carrier power is given as 8 kilowatt. The modulation index is. So P USB and P LSB are given, and we have to find out what is my modulation index. So what will you do? You guys already know that total power was PC into 1 plus mu square by 2, which is nothing but PC plus PC into mu square by 2. So this was actually your P sideband. So P USB is equal to P LSB, that is half is distributed in lower sideband as well as upper sideband. So PSB by 2 will be USB or LSB. So that is nothing but PC into mu square by 4. Okay, so you can relate very easily what will happen. From here you can relate, PC is already given and USB LSBs are already given. So mu square can be written as 4 times P LSB, that is 2, divided by PC, that is 8. Okay, so 8 by 8, that is 1. So nothing, mu is equal to 1 or 100%. Okay, so this is the very important thing that you have to understand. The total power in AM signal is related to the carrier power plus the sideband power, and sideband power is PC times mu square by 2, and this sideband power is a combination of your USB signal as well as LSB signal. How does it look like? Like, let's say this is FC, this is FC plus FM, and this is FC minus FM. So it looks something like this. So this is your USB and this is your LSB, lower sideband. Okay, and you can see this is your carrier power. So carrier power plus the lower sideband power plus the upper sideband power is all together going to give you the total power in modulation, amplitude modulation. Okay, so in one shot you can find out P USB is equal to PC into mu square by 4. So direct formula you can utilize, or you can try to derive it. So I will always suggest you, in GATE examination, you do not sit ideally, you try to derive it from the base formula. Okay, let us take another question, little bigger question. I'll try to find out all the parameters in one question, which will help you to understand amplitude modulation completely in one shot. So in AM signal, the carrier signal is given C of t is equal to 10 cos 2 pi fct, where fc is equal to 10 to the power 6 hertz. Okay, so this fc is given. So fc is fine. Similarly, the message signal is given as 4 cos 2 pi fm of t, where fm is 2 kilohertz or 2 into 10 to the power 3 hertz. The modulation index is given as 50%. See, the antenna resistance is given RT, which is 5 ohms. So we have been coming using resistance as 1. That's how PT is equal to PC into 1 plus mu square by 2, where PC was nothing but AC square by 2. But here onwards our aim will start utilizing V square by R form or I square into R form. In that case, my AC square by 2 R will come. Okay, so this is how R was omitted, because we were using unity. Okay, so we have to find out bandwidth, carrier signal power, total power in AM signal, power in sideband of AM signals, power in upper and lower sidebands, and the efficiency. All right, so let us proceed one by one. What is your amplitude model? Amplitude of message signal? That was 4. you can take out from these two equations, 4 cos 2 pi fmt and 10 cos 2 pi fct. So fc and fm is given, mu is given, r is given, that all the values I have just written here. Okay, so am, ac, fm, fc, and this mu is equal to 0.5 and r is equal to r is equal to 0.5, r is equal to 5. Okay, now what is the bandwidth? So I told you bandwidth is 2 times message signal, that is 2 into 2, that is 4 kilohertz. Okay, so 4 kilohertz is done. Now pc square, pc is equal to ac square by 2r. I told you just now why. P is nothing but ac square by, or ac by root 2 chi square, so that is 2, and since there is like resistance which is not unity, so divided by r, it is just like v square by r. Okay, so you have 10 square, like AC was 10, so 10 square by 2 into 5, that is 10 watt. Okay, so PC is also done. What about total power of the amplitude modulator? So the total power of amplitude modulator we have been keep on calculating for past some 10-12 questions. So PT is equal to PC into 1 plus mu square by 2, that is going to be PC. Just now we calculated 10. Okay, so please, I will tell you, do not you use PC is equal to AC square by 2, otherwise you will get what, 50, right? 10 square by 2, that is 50 watt. So this is wrong. Okay, why? Because there is a resistance which is included of 5 ohm. Okay, so if you do that, it is going to come up as 0.25. 0.25 by 2 is 0.125. So 1 plus 0.125 times 10. So that is going to be 10 into 1.125, that is 11.25 watt. Okay. Now next question was, what was the sideband power? What was the sideband power? The sideband power is nothing but the total power minus the carrier power. So total power is 11.25 minus 10, that is 1.25 watt. So 1.25 watt is the sideband powers. What about upper sideband and lower sideband power? So half will get distributed. So half will get distributed, that is 1.25 by 2, that is 0.625 watt for USB as well as LSB. What about efficiency? Efficiency you can utilize, you can find out in two manners. First is like sideband power divided by total power, or otherwise it was mu square by 2 plus mu square. So mu you already know, 0.25. So 0.25 divided by 2 plus 0.25, that is going to give you 0.25 by 2.25. So 25 1 ja, 25 9 ja, so 1 by 9. Okay, so 1 by 9 is nothing but 0.111, that is 11.11%. You multiply by 100 to get it into percentage. Okay, or from here also you can find out like PSB by PT. So PSB was what, 1.25 divided by PT was how much, 11.25. Okay, so with this you will be able to get your efficiency. All right, so let me calculate and see, like 1.25 divided by 11.25, so that is going to give you 0.1111, that is 11.11%. Okay, so this is my modulus, efficiency. Okay, so efficiency is nothing but the available power in side bands divided by the available power in amplitude modulated signal. Okay, alright guys, so we will solve more questions in our next upcoming videos. Thank you so much. Bye.